For the introduction, networking projects involve many stages and problems can occur at any stage. Discovery and action dialogue is a collaborative approach that allows team members to work together, share ideas, and identify practical solutions based on successful experiences. What is a discovery and action dialogue? Discovery and Action Dialogue, or DAD, is a collaborative problem-solving technique that helps teams identify challenges and develop practical solutions through meaningful discussions. Unlike traditional methods that focus only on problems, DAD also encourages teams to discover successful practices and learn from previous experiences. This approach promotes teamwork, active participation, and knowledge sharing, enabling better decision making and helping the team to achieve its project goals. Discovery and action dialogue is important because it encourages collaboration among team members. Everyone has the opportunity to share their ideas and experience, which improves communication throughout the project. By combining different perspectives, the team can make better informed decisions and develop practical solutions. The idea also promotes continuous improvement by encouraging members to reflect on their current practices and identify ways to enhance project performance.
The discovery and action dialogue (DAD) process begins by identifying the communication requirements and networking challenges of the smart car project. Then, our team discovers successful practice and technologies used in the system. After that, we identify the potential barriers such as network congestion, communication delays, and security risks. After discussing and analyze the possible solutions, our team select the most suitable approaches, including routing and security improvements. Then we develop an action plan. We create a clear plan that specifies tasks, responsibilities, and timeline. Finally, the proposed solutions are implemented and tested using Cisco Packet Tracer to ensure a reliable and efficient network system. In the Smart Car project, Discovery and Action Dialogue (DAD) is used to identify communication requirements, analyze networking challenges, and develop effective solutions. Our team members discuss issues such as network congestion, communication delays, and security risks before designing and testing the network in Cisco Packet Tracer. This collaborative approach encourages active participation, knowledge sharing, and teamwork, leading to better problem solving and stronger commitment to achieve the project goals. As a result, DAD supports the development of a reliable, efficient, and well-designed smart cars network. For the conclusion of Part A, Discovery and Action Dialogue is a collaborative problem-solving technique that helps teams surface challenges, share ideas to find out the best solutions to overcome the obstacle through a structured discussion. In the Smart Cars project, this approach allows team members to identify communication requirements, analyze networking issues, and implement effective solutions using Cisco Packet Tracer. By constant discussion and collaboration, our team can build a reliable and efficient network infrastructure structure for smart vehicle communication while ensuring the project is complete successfully.
Hi, my name is Shahrina Kamila Binti Shari and my metric number is P12241078. I will explain about part P, which is Smart Car Project. The Smart Car Project is an integrated Internet of Things IoT system designed to enhance vehicle security, automation, and user convenience. by utilizing various sensors, cameras, and actuators. The project aims to create a responsive automotive environment that can be monitored and controlled remotely. Key features of this system include keyless entry through motion detection, a crash detection system that activates emergency alerts, and remote engine management via a mobile application. To make this project successful, I used a few IoT devices, which is wireless router, WRT300N, fan, light, motion detector, door, webcam, smartphone, server, and siren. I already explained all of the IoT device in our report. Now, I will explain about how we do our smart car project in our CISCO packet tracer. First, we set up our topology, which is it have 4 door, 2 motion detector, 2 webcam, 2 light, 1 siren, and fan. And fan is stand for engine motor. Motion detector is for detect motion, and light for emergency light and start or off engine. And door is stand for co-driver door, driver door, passenger 2, passenger 1. And webcam we put at the front and the rear of the car. At the same time, for the server, we put 1 server, wireless router, and smartphone. And we set at the first thing, we set up the wireless router, where we go to the GUI at the wireless basic wireless setting, where we set the SSID is car, and the wireless security for passphrase we use red hat 123, and the security mode we need to check at the WPA to personnel. And then we set the SSID on all IoT device that connected to the wireless router, where we go to each of IoT device and we config to add the wireless. So the SSID we set car, and at the server we tick at the WPA2 PSK. The passphrase is red hat 123. And then we connect the server. We put the server in the CISCO, where it connect with wireless router. We connect that using the copper straight truth option. And then after we put the server, we set up the DHCP server. So the DHCP server, we will make sure the IP address at config, setting, and fast Ethernet 0, it will appear automatically. So the open service is on. The default gateway is still 0000. TLS server still 000, but we change start IP address at 192.168.0.0 for subnet mask 255.255.255.0, and the max number of the user is 512. And then next, we set the DNS server at a wireless router. Wireless router, we go to the GUI setup, the DHCP server setting, and then the static DNS. We put 192.168.0.127. And then lastly, IoT device that we add is smartphone to the workspace. So we set the smartphone at config wireless 0. SSID name, we put car. WPA to PSK, we put passphrase thread hat 123. It's just similar with the step before this. And then we make a registration server, log in using smartphone. We go to the desktop and then web browser, type DNS server or DNS server name, which is we put username admin and password also admin. But at the URL, we also can use IP address or the name of server that we set. And then config the IoT server for all IoT device. And you need to make sure all of your IoT device need to config at the setting where IoT server set to remote server. It has 3 server address, username and password. At the server address, we put IoT_server.com for username admin, password also admin. And all IoT device will appear on the smartphone after we config the server at all IoT. And you can see at all of the slide, I already show you step by step how we make a smart car project. And at the end of this project, we successful. All the IoT device is run smoothly and function. The siren, the webcam, the light, the motion detector, the door successfully on. And last of our project, we put the picture of the car, of the interior in the car, and then we put all the topology in that photo. So that's all from us. Overall, the Smart Car project is a successful example of how IoT technology can be used to modernize the infrastructure of vehicles. The system wireless router and dedicated IoT server offer a unified and centralized solution, ensuring that hardware components are seamlessly connected with user-facing software. The final implementation on proof all device, from the motor of the engine to the emergency siren, can be fully integrated into a single ecosystem and thus monitor and control remotely.